Alright guys, 8.1. This is going to be a long lesson, so get some popcorn. Here we go. 8.1, multiplying and dividing rational expressions. Okay, you've done a lot of this, you guys. You've done a lot of what we're about to do today, but it just looks a lot different today. But you've done things like this, where you take, a fraction like 8/12, and you say, what is in common with both 8 and 12 that I can take out? And it would be 4 in this case, right? Where you have a 4 in common, so you can take that out, and you're left with 2/3, and they mean the same thing. Well, today we're going to do the exact same thing. We're going to first factor these just like they showed here in this middle piece. We're going to factor these guys, break them into their most simplest form. Then we're going to try to eliminate anything that's in common between them to simplify it. Okay, so if you did that in this one, you would get, what's here, and then we would cross-cancel the thing that is in common between them. So the steps to doing this, and what's important to consider is that remember that in the denominator, whatever makes that denominator go to 0 is not included in the answer. So for instance, with this one, even though we cancel that x minus 1, we would say that for this answer, x could not equal 5 and x could not equal 1, because that would make the denominator go to 0, and we can't divide by 0, right? So we have to also talk a little bit about that today as well. So the steps to simplifying: we're going to factor a polynomial completely, we're going to divide out the common factors that are in both numerator and denominator, and then we're going to state the values of the expression that make it undefined. So we're going to say things like x cannot equal, like I just showed you here, whatever makes the denominator go to 0. So for 1a, let's do one here. It says to simplify this and determine when it is undefined. So there's nothing really I can do to the top. The top's pretty much done for me already. Okay. But there is something it looks like I can factor the bottom. So remember here not to forget about this y that's on the outside. So we have y. And then what two things multiply to give me -6, add to give me -1? Well, that would be y, let's see, -3 and y plus 2, I believe. Okay, now we can do some canceling. Now that we have this, these is all, notice that I'm not adding or subtracting anything in here. I mean, I am within pieces, but between the pieces I'm not. So this acts all as one piece, so does this. So I can take things out that are in common. Okay, everything's being multiplied. So there's a y in common on the outside, and then there's a y minus 3 in common here. So what I'm left with here is 4 times y plus 4 over y plus 2. But I have to consider what would have made my original go to 0 when I say, what makes this undefined. So I'm going to say where y cannot equal, so if I put a 0 here, that would turn this whole thing into 0. So y can't equal 0. And then, so that's that factor. And then this factor, y could not equal 3. And in this factor, y could not equal -2. It's whatever makes each of those pieces go to 0, we cannot include in our answer, because then it becomes undefined. Okay, so here's 1b. Let's go ahead and do this one. So 2z, z plus 5. Let's factor this guy if we can. So that would be, let's see, z, what two things multiply to give me 8, -8, add to give me 2. I believe it would be 4 and 2, so maybe +4, -2. So z plus 4, z minus 2 should work. Okay, and then on the bottom, everything's already factored for me. Z minus 1, z plus 5, z minus 2. Okay, so let's cancel where we can. All right, so this and this are in common, this and this are in common, and I'm left with 2z times z plus 4 over z minus 1. And then z cannot equal, I got to go back to this guy right here, the original. Z cannot equal 1, 2, or -5. Okay, and that is your answer. All right, let's keep going here. So this is example 2. It says, for what values is this undefined? So I got to figure out, I got to factor this thing and see where it's undefined. So if I factored this piece here, two things that multiply to give me 10, add to give me -3 would be, well, it looks like 5 and 2 might work. So let's do x minus 5, x plus 2, I believe is how that would factor. So we know that x cannot equal 5 or -2. Okay, so for this one, 5 and -2 would be answer choice G. Now, sometimes we have to, if we factor out a -1, we can change how things look. For instance, if I had something like 4 minus x, and I wanted to try to cancel that with x minus 4. Is that right? Yeah. So I could actually, if I factor a -1 out of this, then I would be left with, on the inside, if I take out a -1, I would be left with -1 times -4 plus x, which can be rewritten as -1 times x minus 4. So notice if I wanted to try to cancel x minus 4 with 4 minus x, if I take a -1 out, I can make those things line up, but I'm left with that -1 on the outside. Okay, so sometimes we have to factor that -1 out. So here's some examples of that. So for this one, notice here, to factor that, always think, can I factor this? Yes, the first thing you always ask yourself is there something I can take out of both pieces? And there is, z, and I'm left with x minus 4. And then in the bottom, I have z squared, and then I have 4 minus x. Okay, so this is one of those cases where these look very similar, but I can't just cancel these out. So what I'm going to do is, I'm going to see if I can take a negative out of one of these. So if I do it out of the, let's just take it out of the bottom, since this looks more conventional. If I take a -1 out of the bottom, okay, so I'm going to do that, but I'm going to write it over here. So I'm going to keep the top just like it is, x minus 4, and then I'm going to change the bottom to -1 times z squared. And if I take a negative out, it still has to remain the same value, right? So I took a negative out of both of these. So this becomes -4 plus x, or x minus 4. Okay, now that I've done that, I can cancel these, and what I'm left with is z, negative z over z squared. But I could take a z out of both of those, so it's going to be -1 over, and that negative sign can go, numerator or denominator, doesn't matter, but -1 over z. Okay, and then for this one, since we're just simplifying this, they don't ask us to say what makes this go to 0 in the denominator, so we're done. Okay, so that's 3a. 3b, kind of the same deal here. Notice up top I can take an a, b out, and I'm left with b, because there was 2 of them there, minus 5. Then on the bottom I have 5 plus b, 5 minus b. Okay, so I got to it would be easier here to make this one look like one of those two. So if I take a negative out, I have -ab, and then if I take a negative out, this turns to -b plus 5. So those signs hit the change up top, over 5 plus b, 5 minus b. Okay, the -b plus 5 is the same thing as 5 minus b. So these can cancel, and I'm left with -ab over 5 plus b. Okay, so sometimes you have to take a -1 out to make this work. Now, when we're multiplying and dividing, the rules are the same as when we have fractions. Okay, so they're the exact same. And that is, we're just going to multiply straight across. So if you have a simple fraction, like a over b times c over d, this is just a times c over b times d. Right? So that's all we're going to do. With division, remember that you need to flip it and multiply. So if you have a over b divided by c over d, remember, this is very important. If you don't remember this, get this in your notes and practice this a lot today. That's the same thing as multiplying a over b times d over c. Okay, so let's go ahead and do some of these. Now, this one's a multiplication, so we don't have to worry about flipping this one at all. And let's see if we can do any kind of simplifying before we multiply. So is there anything in common with numerator and denominator? So what I like to look at is like this piece and this piece look like they have a 7 in common, right? So I'm going to take a 7 out of both. That leaves this as a 2 and leaves this as a 3. And then the other two, 12 and 8, those have 4s in common. So this would be like 2 and this would be like 3. Now, notice I have 2 over 2 and 3 over 3. That's equivalent to 1. I encourage people to still maybe multiply it out because it's not always going to be that obvious. So if you did 3 times 2, you get 6. And then we have c to the third, d squared, a squared, b. Okay, so I just multiplied all those out. There's nothing in common there, so I didn't have to add anything with my exponents. And then at the bottom I have 6. 3 times 2 is 6. And then I have, since this started with a c, I'll start with c squared, d, a, b. And now let's just, if there's anything in common, we're going to get rid of it. So that 6 and 6, that just becomes a 1. C to the third over c squared just becomes c in the numerator. D squared over d just becomes d in the numerator. A squared over a just becomes a in the numerator. And then b over b is just 1. So this is the same thing as c times d times a over 1, which is equal to, if you want to put them in order, a, c, d. If you're OCD, you might want to make that ACD so that it's in alphabetical order, but it means the same thing as this, and I would accept either answer. Now for 4b, we're going to do this one here. I'm going to do the same kind of thing, and I encourage you to actually try this one on your own. So pause the video, try this one on your own. But here we go. Let's do this. This is, we'll do this kind of quickly. So 6 goes into both. 1, 3. 3 goes into both of these guys. 7, 5. And now let's multiply. 1 times 7 is 7. And then I'll put it in alphabetical order. So a to the third x, y. And then on the bottom I have 5 times 3, which is 15. And then I have a, b squared, x to the fourth, y. Okay, nothing's in common with 7 and 15, so those are going to remain. A's have something in common, so there's going to just be 2 left up top. The b squared has nothing in common, that stays down. The x's have 1x in common, so it's just going to be x to the third in the bottom. And then y over y just stays as that, and we're done. Okay, so that's 4b. For 4c, we're going to now do the same thing, but we have to flip and multiply, right? So this is 16mt squared over 21a to the fourth b to the third times 7a squared b squared over 24m to the third. So all I did was rewrite this as multiplication and flip the second fraction. Now that I've done that, I can cross cancel things here to simplify things. 8 goes into both of those, so that's 2 and 3. 7 goes into both of these, that's 1 and 3. And now let's go ahead and rewrite this. So 2 times 1 is 2, and then I have, we'll go in alphabetical order, a squared, b squared, mt squared over 9, a to the fourth, b to the third, m to the third. Okay, now let's see what we can cancel. 2 and 9 have to stay the same since there's nothing in common with those things. Then I have a squared down below, b down below, and then m squared down below, and t squared in the numerator, and I am done. Okay, for 4d, which you're going to do on your own, we're going to, again, flip it, right? Flip the second number and multiply. So times 16a squared x over 6x squared y to the fourth. Again, cross cancel, right? So we're going to cross cancel these things. 8 goes into both, 2, 5. 6 goes into both, 1, 2. I'm left with 4, x to the, well, I guess we'll go in alphabetical order again. So I have 4, a squared, x to the fourth times x is going to be x to the fifth, y squared. And then the denominator, I have 5 times 1, which is 5. And then I have a to the fourth, b to the fourth, x squared, y to the fourth. Okay? And then I'm going to just let you simplify this. But I mean, this goes away, this goes away. because, well, I guess I'll just do this. Okay, so we have 4/5, which stays the same. A squared here, because that simplifies. Then I have a b to the 4th down below, because there's nothing that cancels with that. And then I have x to the 3rd up top. And then I have y squared down below. All right, and that's my final answer for 4D. The final two pieces, final two examples here, guys. Sorry, be patient. Factor first. Sometimes it's easier for you to multiply, divide rational expressions if you factor them first. Use the method when you have a polynomial in both numerator and denominator. So we're going to factor first, right? So for 5a, and what I'm going to do is I'm going to do these. I'm going to do one, and then I'm going to give you the answer for the second one, and I'm going to have you work it, okay? So just to save some time. So I just want to make sure that you understand how to do this. So for 5a, is there anything in common with 8x and 20? And the answer to that is yes, 4, right? 4 can be taken out of both, and I'm left with 2x minus 5. So you're going to want to factor first. Okay, for the bottom piece here in 5a, two things that multiply to give me 35, negative 35, add to give me 2, that's going to be x plus 7, x minus 5. Okay, so I'm factoring here, and then I'm going to factor this guy. The two things that multiply to give me 10, add to give me negative 7 would be x minus 5, x minus 2. And then on the bottom here I have 4 times x squared minus 4. This is the difference of squares, which, man, you guys got to remember a lot here. Perfect square, I can factor this. This is the same thing as x plus 2, x minus 2, right? This thing factors to that. Okay, now that I have that done, I can cancel where I can in numerator and denominator. So x minus 2 is in common in numerator and denominator, so I can get rid of those. What else do I have here? X minus 5 is in common, I can get rid of those. There's a 4 in common, I can get rid of those. And so what I'm left with is 2x minus 5 on the top, and on the bottom I have x plus 7 and x plus 2. Okay, so that's my final answer for that one. And let's keep cruising. They don't want to know what makes the denominator go to 0 here, so you guys are good for that. That's just the first example there. For 5b, the only thing I'm going to warn you about with 5b is that you're going to flip this and multiply it, right? So for 5b, just be very careful to make sure to do that. Otherwise, you're going to end up with the wrong thing here. And so I want you to do 5b on your own just to save time, but let me just set it up for you. So this is going to be times 6x plus 42 over x squared minus x minus 12. So remember, factor these first, then cancel the common factors. And what you should end up with at the very end of this is 6x minus 30 over x plus 3 squared. Okay, that's what it's going to equal, so make sure you work the problem and figure that out. For example 6, the last piece here, this is where you have a fraction divided by a fraction. Okay, and you know this lesson is just getting way too long, so I'm not going to spend a lot of time on this, but just remember that that's just division. So I'm going to write this as x minus 2 squared over 2 times x squared minus 5x plus 4 times, and then I'm going to flip that. So 4x minus 10 over x squared minus 4. Okay, so, and then I want to factor this, right? So this is the same thing as x minus 2 times x minus 2, right? Over 2 times x minus 1, x minus 4, I believe, is what would give me this guy. And then multiply that by 2 times 2x minus 5. And then this is a difference of perfect squares, so this would be x plus 2, x minus 2. All right. So this cancels with one of those. And then is there anything else in common? It looks like a 2 is in common. And so what I'm left with here is 2x minus 5 okay, times x minus 2 all over x plus 2, x minus 1, x minus 4. Nothing's still in common, and I'm good. I'm done. All right, for 6b, hey, remember, this is a difference of squares, perfect squares, right? So I just want to make you aware of that. So that's going to be x minus y, x plus y, right? Over, this is a difference of squares. This is going to be y plus 7, y minus 7. And then you're going to multiply that by the reverse, right? Y plus 7 over y minus x. And it's not letting me write over there, so let me see if I can zoom in here. Anyway, you guys get the gist of it. That's supposed to be an x. Okay, so real quick, I can cancel this, but then I have y minus x, right? So what I want to do is, for that y minus x, I want to see if I can make it look like one of these things to cancel it. So if I take a negative 1 out of that, I'm left with negative y plus x, which is negative 1 times x minus y, right? So I can do that for this piece right here and cancel it with this one. And so when I do that, I'm left with x plus y in the numerator, and then in the denominator I have y minus 7. And then when I canceled that out, I had a negative 1 there, right? So I had to take a negative 1 out. So just be mindful of that. And then, so I'm going to put a negative out in front of this whole thing now. So I'm almost done with this, but I don't want that negative hanging out right there. So this would be negative. You could do a negative on the outside and just keep it the same, like x plus 7 over y minus 7. Or you could distribute that negative to both pieces that are here, and your textbook might do that. So just to be prepared, that would be negative x minus 7 over y minus 7. That works as well. Okay, either way. All right, guys, I know this is heavy and a lot of information and a lot to remember from factoring. We'll do a lot of these in class together as well. We'll catch you guys